Right, we will start our next session then, and we'll invite our next speakers, who are Ignacio and Kieren. Ignacio's there, great, to come to the stage. I can't see if Kieren's around here. Right in front of me, there we go. Come onto the stage as well. Join me on the stage while we do this. And Ignacio, you're going to start us off, aren't you? So Ignacio's going to start us off. We're on AI for RAN efficiency and planning. If you'd like to just join me on here. And Ignacio Gonzalez is Business Development Director, EMEA Telco for Red Hat. So, Ignacio, it's all yours.
Good morning, everyone here and there. I want to try to explain what we are seeing now from Red Hat when we talk about radio access network and how AI can help. I'm going to do a very quick journey. The first time is, yes, I think everybody agrees on that. The final goal, the autonomous network, which is a little bit of automation, AI, analytics. And the final outcome should be understand, detect, and act in order to be self-managed. We can see right now, and someone talk about some outages that we have lately that we are still not there. And the final benefit, very clear, we're going to be able to use the technology even more. That's very important because it's going to help telcos to reduce CapEx. We have heard several telcos telling us that the current CapEx investment revenue ratio that they have today, they are expecting to drop between 2-3 points. And also from an operational point of view, we are expecting a significant reduction because it will be easier to operate and maintain networks. Very important for us, at least here in Europe, still the environmental side of this. We're going to consume less energy and will be probably more greener energy. Okay, the problem of data, and Ahmed talked about this. Today, we have data silos everywhere. We have been talking about data and how we can clean the data and how can extract information from data for many, many years, more than 10 years ago. Who remember when we talked that data science were needed for telco? We're still there. And also the amount of data produced is humongous. What is the expectation? Is visible data, accessible data. Ahmed mentioned clean data. I can go one step further, which is drinkable AI data. This is what we need. Okay, now let's talk about what we are going to discuss, which is the day operations, and we focus on day 0, day 1, and day 2. Day 0, planning and design. Nothing new in terms of using AI and prediction. Microwave tools, radio planning tools, they have been using prediction tools telcos have been using prediction tools for many times, many, many years. I remember a long time ago when I was a part of Vodafone, 10 years ago, smart CapEx, smart planning. So the idea is as many layers of information of data you can put, the final outcome is going to be better. So what we try to do now, thanks to GenAI, is moving to a framework where we are going to have even more layers of information to help us, to help telcos to make this decision to obtain this optimized network design. And the final benefit, probably lower CapEx and better performance. 3 examples of what telcos are doing, 3 use cases that I put there. And I'm not going to go through them, but there's very, very, very typical one. In terms of prediction, the modeling for capacity, how they're using the spectrum, how can they get the most of this spectrum. Now we're talking about millimeter wave. In these urban scenarios, how they're going to be able to deploy small cells, indoor, outdoor, for thanks to AI. And the final one, this is from Telefonica, how they can use satellite image to detect where in rural sites they can improve coverage. Day 1, build and deployment. In this area, I believe, has been the area where telcos didn't do much in the past. But right now, the potential is very, very, very great. Why? The idea here is having this dynamic network configuration. Ahmed talked about this. And digital twins is going to help a lot. Think about if you can, thanks to this digital twin, test different configurations for different sites, for the same site in different moments. If you have typical sites that they are very, very busy during certain type of the day, et cetera, et cetera. So at the end of the day, the idea is to get a fast and a highly efficient deployment. Again, 3 use cases that I'm not going to go through them in detail. Digital twins, I can take many, many examples. I took this from Vodafone in order to do and test the 5G slicing before it's implemented. Second one is very, very common in many operators, how they can enhance the mobile networks in terms of energy efficiency from the design to the deployment. And the final one is coming from SoftBank. We are working with them here in terms of how they were able to improve the uplink throughput around 30%, thanks to purely, it's purely AI, it's purely about a language model, thanks to this transformer model. Day two, I'm not going to talk much about day two because in terms of what we're going to cover here is not the main topic, but Ahmed mentioned, and that's what the industry is putting. It's putting a lot about Gen AI, agentic AI, and the final goal here is, thanks to this, having this dynamic network operations and optimization, and again, when they're talking about network autonomous operations. 3 use cases. Again, I'm not going to go through this because just for the sake of time. And now the question is, okay, you're Red Hat. What are you talking about here, right? So at the end of the day, what we want to achieve is this. We need to have a telco cloud native solution. That's the reason why of the cloud. When we're going to have this clean data, the data lakes that we're going to need to have over the same platform, over the same framework, together with the different AI applications that we want to implement, the language models, how we're going to tune these language models, how we're going to get and optimize the inferencing and the outcome of this language model, all of this done over the same platform. This is the value that we play here. So once we have this ideal scenario, you put on top this day one, day zero, day one, day two operations, and the question and what we are seeing from the operators is, okay, who is going to operate the network? So from day zero, we still believe that it's going to be a man in the loop. That's what we are seeing and what telcos are telling us, and it's going to be this user AI dynamic collaboration. Very similar for day one. It's going to be a man in the loop in many of the activities. At the end of the day, someone has to decide. And when we talk about day two, I do believe that is a different way. So it's going to be more about agentic. It's going to be more about autonomous agents doing this dirty job daily of cleaning alarms, check that the network is performing as expected, et cetera, et cetera, et cetera. Very important. This retrofitting, so whatever it is the outcome of the day two should be the input for the day zero, and all the way around. At the end of the day, if we can intertwine the data that is coming and the performance that is coming from these three different stages, we will improve the overall operational efficiency of the network and people working on there. And just my final slide. I'm taking this is from Vodafone. This was published in November 2024. Google and Vodafone working together, pretty similar of probably what Deutsche Telekom is doing, but they published, and it's good. So, and they tried to explain in the daily activities of these network engineers how they can get the most of Gen AI, et cetera, in terms of improving and adding value. They found so many fantastic use cases that, maybe we need to invite Vodafone to explain what is the current status of this, right? Because after 1 year, based on our experience and what we are seeing, it's very easy to start talking about use cases, experimenting with these use cases. But the implementation and the execution of those cases is when problems are showing up. How you can fetch data, what type of data you can use, how are you able to tune the language model, how you can make sure that the outcome of this language model is correct, how you're going to make sure that you can optimize this inferencing model. These are the real problems, and this is where moving from this experimental to real use cases, we are seeing a big hurdle right in the middle. Wow, I'm finished. So I hope I was very simple. I tried to touch upon 3 different concepts, and now I'm happy to take any questions.
Fantastic. Ignacio, come and sit down next to Kieren there. That's fantastic. Well done. Thank you very much indeed. I'm sure we've got some questions there. Let's put these microphones to use. Any questions from this side of the room? Do I see all these hands going up? That's so many hands, I can't pick one. Oh.
I've got a mic right
You've got to make ready. Come on, Tony's here with the microphone. Make Tony work. Oh, he hasn't got to go very far.
Hello, thank you. Good morning. Yvon Rouault from Keysight. Could you elaborate a bit more on the digital twin contribution? Because you mentioned it can be used for testing, right? Could it be used as well, and I believe so, for training the AI-based applications with definitely clean data right from the beginning instead of using raw data and clean them, and in particular to produce some very rare events or anomalies or things like this, right? Instead of counting on the chance to get them from the network.
Of course, I think the training of the network, because at the end of the day, is what you're trying to do there. Digital twins is going to be the punching guy that you're going to get to see, okay, how much can I stress the network to achieve in streaming circumstances, what is going to look like the final outcome and the final performance of the network. So yes, the answer is, from my point of view, Kieren, I don't know if you want to add anything, but yes, of course, yeah.
Yeah, no, I think it's the what-if scenarios on digital twins that is really good. So you can create your replica, you've created your twin, and then you do all of those different scenarios, those what-ifs, and that then allows you to play around, so you don't have to make mistakes into the network.
Great, thanks so much, and great question. Thank you very much indeed. Tony, you got a new question?
Yes, yeah, okay, here. Virtuit Koshi from Mavenir. Bit more for Ignacio, but also for Kieren. You mentioned the telco cloud native conditions. To what extent do you think what you presented will bring benefits from the AI if the networks are not cloud native or partially cloud native?
Good question. I truly believe that the more cloud native the network and the applications and the workloads there, the higher it's going to be the gain to get the most of AI, of course. Doesn't mean that if you don't have cloud native, you cannot use and you cannot get any benefit for AI. I don't think so. Yes, you can get certain benefit, but it's going to be very limited. Think again about all the data. The more or the wider is the overall network in terms of elements that you can fetch the information, you can fetch data, and you can analyze all together to understand what is going to be the next one. Plus, this disaggregation that we have, that you can isolate it network functions one by one in order to even decide which actions you want to apply there, I think is going to be a real deal. To me, I think the best way to get the most of AI, it has to be based on a cloud-native network for sure. But that's my view here.
Great.
I don't know.
Sorry. Do you want to respond?
No, that's fine.
No, fun.
Ignacio, thanks so much indeed. Tony's got his hand is spotted another question, and we've just got time for one more question, I think. So let's get this one in.
Good morning, Luis Santos from Cellfocus. Can you elaborate a little bit in which capacity did the transformers enable 30% extra throughput in the network?
We have one minute here, but at the end, what these guys, by the way, is done in real time. So they are applying AI, generative AI, and AI capabilities in real time, which when we talk about radio, it's so fantastic. What I try to do is checking and measuring interference in a nutshell, in order to eliminate them and try to predict what is coming next in order to have this uplink throughput. There are a couple of blogs there in terms of explaining what SoftBank achieved. So I really invite you to go there. Just here, we don't have much time to explain there. But at the end of the day, it's about how you can get rid of interference that you have there to improve the overall throughput.
Great. Ignacio, thank you very much indeed. Great question. Thank you. We're going to move on to our next presentation now. So a round of applause for Ignacio. Thank you. Kieren, we'd like to take the lectern for your presentation. And Kieren Ashlee is EMEA RAN Systems Architect, Telecom Systems Business at Dell Technologies. Kieren, all yours.
Yeah. Thank you very much. I think it was really interesting to see what Ahmed presented this morning. There's some tangible results coming through, and also from the study that TelecomTV. I'm hoping in my presentation to give you some numbers as well. So we've got some examples, but let me start off. So I work in the telco systems business in Dell. We're a dedicated unit within Dell to put together hardware and software dedicated for telco business. So just to start off, of course, from a Dell perspective, we see 4 pillars for AI, the opportunity across the whole of our industry. There's new monetization, of course, there's improved customer experience, improved business and operational productivity, but the one we're talking about today is how do we optimize network performance. So I hope to show you some examples and how that can be achieved. So the ask I was asked to do for this was to look at RAN efficiency and prediction. So and how does that apply to spectrum, and how do you manage the cellular network? So there's, just looking at this, and there are 4 main topics we can talk about. So the first one is AI and machine learning, of course, for optimization. You can create traffic forecasting models that can be time series analysis, deep learning on graph-based techniques, anomaly detection, how we reinforce the learning from those anomalies that we see in the network. And there's also, as we on the other presentations, with the RIC and with the SMO, you can use neural schedulers in the X apps and in the R apps, so you can get the best scheduling. So there's companies like Cohere that are able to do channel estimation and to get better allocation in there. I think that's the difference between traditional RAN, where obviously the network equipment providers have done their own modeling and how they can do their resource allocation. I think the exciting bit with Open RAN and Cloud RAN is how we can use the X apps and the R apps to get better channel estimation, as an example. So that's the first. The second technique we can use, as we just spoke about, is digital twins. And I do believe it's that what-if analysis that's important for that. So you can create your replicas, you can play around, you can do your holistic scenario testing, and that will help you to then be confident in how you can then deploy that into the network. The third type of model is to use Gen AI, of course, and use LLM and how we've trained those. So, of course, Dell has created a Dell AI factory with NVIDIA, so we can use that as a platform, and then we've trained that with the natural language interfaces retrieved, and we also use RAG as well to create insights from the network data. The fourth one is, of course, predictive maintenance and also energy optimization models. So we can apply that to KPIs, logs and alarms, and we can predict when the failures are going to happen. I mean, fantastic. I mean, at the moment, the operations team spend a lot of time correcting problems in the network. If we're able to now predict those accurately, we can save a lot of time into the network. Okay, so some examples for you of what we've seen from telecom operators. So we, in Dell, we don't create the workloads or the software for AI. We've worked with partners. So one of our partners we work with is a company called Apanga, and they do predictive analysis and they optimize cell traffic. And it's all about looking at the congestion in the network, how do you improve the energy use. So here's one example. So in Mexico, the operator there had a challenge. He's got 10,000 sites handling about 320 gigabits per second of traffic, and it goes across their 6 data centers. So they knew they needed to expand their capacity. So they've used AI with the Panga to look at those and to look at the sites that needed to be upgraded, but in an intelligent way. So once they applied their AI modeling and their prediction to that traffic, the result was from that an 18% fewer sites were upgraded. And that also, interestingly enough, improved their busy hour user throughput as well by over 20%. So that's one example. Another example, we work with a company called ERA Technologies with their NAVAC platform. It's a Gen AI platform that's been used, and it allows you to experiment, put the code in and into the network based on their modelling. And the result from that was, and I think it ties up with what you showed, Ahmed, is that they were able to show a time reduction of about 20% in the network anomaly detection on the network they had. And the last is Kinetica. So we work with them, again, a Gen AI-based platform, and they do network troubleshooting, and they also do geospatial analysis of the network. So there's a US tier 1, and they had a interactive agent for network troubleshooting, and they were able to show a 4 times faster troubleshooting with a greater than 90% accuracy. Another US tier 1 uses geospatial analysis. Here, it took 4 hours with CPU-based technology to look at the data sets and process that. With a GPU-based solution, it took less than 10 minutes, so a 95% reduction. Now, these are 2 US tier 1s. Later on this evening, there's a networking dinner and drinks. If you come and buy me a drink, who knows? I might be able to tell you a little bit more about those US tier 1s. So what are the enablers for this? So Dell has put an AI factory together with NVIDIA. So it's an AI model training, inferencing, predictive simulation across our hardware, of course. And the Dell AI factory takes data as an input, good quality data, of course. We have our underlying infrastructure. We have an open ecosystem to work with partners who are developing their AI platform software. We create a level of services on top of that to deliver, to help enable and to push the data through. And then you've obviously got to have your use cases as well. And finally, our products also enable AI. We've worked very closely with NVIDIA. We have in our edge servers, our XR8000, and please, we've got one on our booth outside the ballroom. It has L4 GPUs in there. If you need to use that processing at the edge of the network, if you've got low latency, and we've also got in the core network with our data center servers, the R760, L40 GPUs. So they are there, they're ready to be built to roll out into the network. And it's really where you use those GPUs at the edge of the network where you need the low latency type applications. If you don't need low latency, obviously you built that into the data centers. And that is it. Thank you.
Kieren, thank you very much indeed. Come and sit down. Thanks very much, Kieren. Let's see, go to our audience and see if there's any questions for Kieren. There's one in the front now. Who's got the microphone? I am looking around. Here comes Alex with our second microphone. Very good. Powered up and ready to go. It's just about the second table down.
Hi, I'm Ron from Rad Data Communication. You spoke about digital twin. Mm-hmm. And when we are emulating the network, some of the devices are hardware-based. Mm-hmm. And I assume that the digital twin is a software-based virtual. So is there any problem? Actually, it will not give the same performance. So how you overcome this?
Well, I guess, so one answer is if they're using the same chipset, you can get similar performance to that. Or secondly, we have an open telecom ecosystem lab. So the hardware could be used and simulated in that environment. So I think if you've got the same underlying hardware platform and the chipset on there, you can use that to get the right performance for your digital twin.
Okay.
Thanks, Kieren. Any more questions for Kieren or Ignacio? Well, he's here as well. Any more questions for anybody? Any more questions for anybody? And just a reminder, while we're here to our online audience, there is a question box on the website. If you want to send us some questions at the break, I'm going to have a look at the questions that we've had so far and pop those into the conversation. So if you're not here in person, you can still send us some questions. Alex's question at the front here.
You mentioned earlier about siloed data being a key issue. I think in my 30 years in telco, siloed data has always been a problem. Could you sort of dig a little bit deeper about how you're changing the issue of siloed data and bringing it together?
The idea at the end of the day is not only that it's isolated. One of the things that we try to do when we try to build this common platform is able to fetch this information, this data, in let's say, in the most real-time point of view. So sometimes you need to have the information, you need to fetch for that, and it's take forever. So if the use case that you want to implement there is based on real-time capabilities, it's not going to happen. So what we are trying to do is, thanks to having this common platform, and the way that you can extract information and fetch information and data from that platform is the way that we're going to be able to reduce data silos. Is going to be possible to have non-silos in the network? Probably not. The idea is to reduce that whatever is needed.
Great, thanks Ignacio. Thanks for that. I think we may be running out of time now because we've got a break coming up. I do want to pick up on, you said earlier that maybe Vodafone should come and present. Well, look, listen, there's an open invite to every single operator out there to come and talk to us, and we expect at next year's event to have a lot more operators talking and telling us what they've been doing these past 12 months. Spoilers there. Right, I think we should take our coffee break. We have a break coming up. We've got snacks, teas and coffees outside the ballroom there, outside the doors to my left. And whilst you're there, and whilst you're chatting with our presenters out there and asking them more questions, do take time to visit our exhibitors and all those pods, the pod people. We'd love to see you. So first of all, let's have a round of applause for Ignacio and Kieren. Thank you.